Hi, so today we will be going through Pythagoras Theorem. So what is Pythagoras Theorem? So Pythagoras Theorem is essentially what is underlined here. A squared plus b squared is equal to c squared. And this formula is very useful for solving the sides of a right angled triangle as we have below. So typically C is going to be the hypotenuse, and A and B are going to be the other sides. And if you don't know what a hypotenuse is the side that is opposite the right angle of a right angle triangle. And so this formula here is very useful for solving, and we are going to go through some examples here. So let's copy here, paste, to here. Get rid of those. So let's have a first example, right? So in our first example, we are going to have a one side 2, the other side 3, and the hypotenuse, we don't know. It's going to be an unknown. So we're just going to label it as C. So what are we going to do? We need to substitute this into the formula. So we have a squared plus b squared is equal to c squared. And so in the have this as a, this side is b, 3 is b, and c is unknown. So 2 squared, change it so it looks a bit different. So 2 squared plus 3 squared is equal to c squared. So we got 4 plus 9 is equal to c squared. It's the same thing. So 13, or c squared, is equal to 13. I'm just switching sides just to make it look easier to read. So c squared is equal to 13. Now this isn't our answer. So what we need to do now is we need to square root both sides. Make it look a bit better. There we go. We're going to square root both sides. So we got c is equal to the square root of 13. And we're going to leave it like that. Obviously, if there's a question that says that has units, most likely there is going to be centimeters, meters. You're going to include that. And we're going to leave it as the square root of 13. We're going to do some questions later on where we actually have significant figures and decimal points. So go on to the next one. So now let's say we know the hypotenuse, right? So we say that's 8 and one of the sides is 4. We're just going to label this as B. Right? So again, we're going to plug in the formula. So we got 4 squared plus b squared is equal to 8 squared. So that's 16 plus b squared is equal to 64. Now 64 minus 16, that is 48. So b squared is equal to 48, right? So we got minus 16. And so we're going to square root both sides. So b is equal to square root of 48. Now, we can in fact simplify this, and we can separate this into look like this. So we've got 3 times 16. So the square root of 3 times 16 is the square root of 48. So if we separate this, we get square root 3 times the square root of 16. The square root of 16 is 4. And so we can have 4 roots 3. Technically, you can have minus 4 root 3 as well, but because it's a length, that's not a valid answer. We can't have a minus length. So 4√3 is the only true answer in this type of question. So make a few more. Got 2 more examples to show. So now this time we are actually going to have the significant figures and decimal places. So let's say we're going to do this 1 to 3 significant figures. And we have a side that's 5 and another side that's 7. And we're going to label this unknown as C as well, just because it's the hypotenuse and it helps us to remember to plug it in the formula well. So so we've got a squared plus b squared is c squared. So again, 5 squared. So yeah, like using different for the calculation. Okay. So 5 squared plus 7 squared is equal to c squared. And that's 25 plus 49 is equal to c squared. So we add that together. 5, that is 5 to 49 is 54, plus 20 is 74. So c squared is equal to 74. And we're going to square root both sides. So c is equal to square root of 74. Now, because we're doing this to 3 significant figures, we're going to actually need to use a calculator. So I have my calculator on, well, it's on the screen on the side. One day I'll figure out to put it on there. But anyways, 74 square roots. So that gives us 8.60 to 3 significant figures. 8.60. Now let's assume, let's do the next question. We're going to do this to 2 decimal places. 2 decimal places. So we got hypotenuse, which is 9. We have a side, which is 4, and we have an unknown, which we're going to label A. So that means we've got a squared plus 4 squared is equal to 9 squared. I'm not going to change that because I can't be bothered. So a squared plus 16 is equal to 81. And now minus 16 from both sides. That gives us 1071, 65, yeah. So we got 65 equals a squared. Square root both sides. A is equal to square root of 65. Now putting that into a calculator, square root of 65. That gives us 8.06 to 2 decimal places. 8.06 to just 2 decimal places. And that's it for our examples. So we hope this will help you to remember how to use Pythagoras Theorem. You know, if you need to go over it, maybe go through the questions, cover up the workings out, try it yourself to see how you do. And if there's any, subjects that you want me to cover that I haven't covered so far, so please check first. But if I haven't covered it yet, do let me know. Thank you.